What if I told you there is a simple step-by-step method to find a root of any function that changes sign in a given interval? No complex calculus, just a logical way to cut an interval in half until we find the root. In today's video, we will break down the working rule of the bisection method in a clear and a very structured way. By the end of this video, you will understand that how to apply it and why it's such a reliable technique for solving equations. So in the step 1, we will define the equation. We start with a function f of x and want to find its root, meaning we need to solve f of x is equals to 0. In the second step, we need to choose an initial interval, that is our AB. So we select 2 points, A and B, such that f of A less than 0 and f of B greater than 0, or vice versa. Or we can say that f of A into f of B must be less than 0. This means that the function has opposite signs at A and B, which guarantees that a root lie between them. This is actually by the intermediate value theorem. In this step 3, we will find out the midpoint. That is basically the formula for finding the bisection method. So we compute the midpoint of the interval. Which means that x1 is equals to a plus b divided by 2. After that, we will evaluate the function at this point. Which is f of x1. After evaluating the function, there are 3 cases can occur. Number 1, 3 cases occur. So one is if f of x1 is equals to 0, it means that we have found the root. In the second case, if f of x1 is less than 0, it means that the root lies between x1 and b. So we update the interval AB to x1, b. That is our updated interval. Third case we have if f of x1 is greater than 0, it means that the root lies between a and x1. So we update the interval to a comma x1. In the step 4, we repeat the process. We repeat the process by using the updated intervals and can calculate the next approximation. So the next approximation, we just simply say that we repeat the process and calculate the next approximation. So the next approximation should be x2, x1 plus b by 2 if the root between x1 and b. Or we simply say that the next approximation should be x2, that is a plus x1 by 2 if the root between a and x1. So this iterative process continues until we reach a predefined level of accuracy, meaning that the difference of b minus a should be very small. So in the next step, that is our 5th step, we stop when desired accuracy is achieved. So we simply say that the process stops when the interval become sufficiently small or when f of xn is close to 0. So the final approximate, or we call it the final midpoint, is taken as our approximate root. And that's how the bisection method works. By systematically cutting the interval in half, we get closer and closer to the actual root with each step. So this method is very simple, reliable, and widely used in numerical analysis. So if this explanation helped you, make sure to like the video, subscribe to the channel, and hit the bell icon so you never miss any future videos. Have any questions? Let me know in the comment below. Thanks for watching, and I will see you soon in the next video. Take care.